I want to welcome everyone to today's webinar series on Generative Entrepreneur. This is where we help our executives and our developers accelerate their generative AI applications to the marketplace and deploy them at scale to production. My name is Jason Virtue, and I'm a partner solution architect at Microsoft. I work within the global partner solutions team within the Americas, working with independent software vendors and system integrators. I also work within our connected community within Microsoft as a global AI and ML practice lead. And I help our partners, our customers, and employees with both their adoption and readiness issues. I think with this background and my passions for analytics, AI, and business, I can bring a lot of domain expertise to these talks and my passions and hopefully help you on your journey with generative AI. Today's title for our webinar series is called Generative AI Fundamentals. For our agenda today, I first like to go into the definition of generative AI and then help you understand the catalog of models available. Also, I like to share what tools are available within the Azure platform and then jump into the journey that you'll be on when going and adopting generative AI. At the very end, I'll provide some learning resources so you have the opportunity to learn more post this session. I hope this talk will be 20 minutes and this will be a very fruitful conversation for you. Let's jump in and talk about the definition for generative AI so we're all on the same page. So, what is a foundation model? This is a term that was coined by Stanford University, and what they define this as is training one model on a huge amount of data and adapt it to many different applications. And you can see by the different boxes on this slide that there's a lot of different use cases and workloads and applications that you can build leveraging foundation models. Now, I highly recommend to go this link for a deeper understanding on this one. But what I wanted to help you understand, since a lot of us come from the field of artificial intelligence and machine learning, and we're very familiar with the traditional development model, I like to share that and contrast it with the new one that we have with generative AI. In the old days, we were in search of a business problem. Let's try to do object detection, action recognition, churn. Let's try to understand the sentiment or classify these different objects. Each of these were their unique business problem that we were then in search of a unique model that we can use to solve that specific business problem. And then we would bring in data that was very tailored to that particular business problem. And then we would look at the models to see if we overfitted the data or not. Generalization was important, but it was all within that one business problem, model, and data set. And this traditional model was very iterative. Unfortunately, it was also very costly because it took us a while. And that long time to market definitely impacted our success rates at time. In the new world, we are not getting rid of our traditional methods. Those are going to be there and will continue to be there. But when we think about generative AI and foundation models, we really need to think of it as a different perspective. These are pre-built models, and when these are being built, we're using data that is either text-based, image, speech, structured data, or tabular, and also video data that we bring into these models. We'll take that universe of data that we have, or corpus, and train that data and build out a foundation model. That foundation model will be the universal data that came from all those different data sources. And the way that this actually works, or the secret sauce behind it, that really brought in foundation models, are our transformer model. Now, once we build that universal foundation model, we can do different adaptations of that model to help us solve specific tasks, be it with sentiment analysis or image capturing or with instruction following. Now, what's nice about this development cycle is we have one model that has been pre-built, and that pre-built model now can be used across many different business problems that sit out there. We have to test and ensure that it's going to actually be well grounded and applicable to its use case. But I think the difference from the old days to today is we have one pre-built model, and our main task in this exercise would be with model selection, making sure we pick the best foundation model. Now, To transition from foundation models to large language models, I will do this for the rest of the conversation is talk around large language models. Large language models is a subset of a foundation model. We can think of the universe or the actual superset as foundation models, and there's a number of different models underneath foundation model, which we'll explain more in another day. But one of those models are large language models. And I love this visual. This came from Dr. Alan D. Thompson. He actually has a website called lifearchitect.ai. And on that website, he's brought in a lot of great content. I highly recommend it as it relates to not just large language models, but also with AI and ML. So I would recommend to go out there. And why this visual is such a good one is when we look at all the different models available to us, we can think of them based on the size of the model. When we look at the planets, the size doesn't necessarily correlate perfectly with the planets, but when we look at these models, we can think of the size as the number of parameters that a given model has been developed with or trained against. And when we look at, say, GPT 3.5 turbo model, we had around 20 billion parameters. Or if we look at Llama 2, we had about 70 billion. Or if we look at Falcon, we had around 180 billion. Now, the size of those models based on the number of parameters is very important. And you can see how he's classified these as large language models, medium, small, extra small, and nano. And those different sizes that sit out there, he's also quantified an approximate threshold for each category. Why does this matter? When it comes to the number of parameters in a given model, it does not always correlate to its quote groundedness or accuracy. You might have smaller models that are more accurate than larger. But what we do know as we get into more, say, larger models, the greater number of capabilities of those models have, and they typically are more performant. But I would highly recommend to test that out before you take that one as an assumption. Now, along that line, when we talk about large language models and foundation models in specifically, as we increase the parameter size of those models, we'll see new capabilities arising. We might start off with language understanding and grow into something like summarization. And then with summarization, maybe we then start to see that we can do other use cases that sit out there like semantic parsing. Now, we call this emergent behaviors. As more and more parameters are added to a model, the more and more that model can actually do. And that emergent behavior is really what's driving the discussions around parameter size. Now, one of the core things I hope you understand about foundation models and more importantly, large language models is one of our key things that we're going to do as data scientists is choose the model that's best for our use case. Now, what's great about the Azure platform and the offerings within the Azure platform is we allow you to choose whatever model that you want to use within your given business problem. We have a lot of different providers that have published their content into our model catalog, and that's what we call our universe of large language models, a model catalog. We also have other models than just large language, but the ones we'll focus on today are LLMs. You can see the providers, be it Llama with Meta models. If we want to use a Falcon model, Hugging Face has published those. Or if we want to use other ones from Mistral or Microsoft Research, those are available. I list the full set of models available in the catalog based on their provider as of this month, but these are the models available to you. So you can choose what you need and leverage those and test them to see the best fit. You are not required to always use Azure OpenAI service. Now, we talk about the models, but I think it's also important to understand what are the Azure AI tools that are out there? What is the portfolio that we bring to this offering? The core tool set that we have is called the Azure AI Studio. And think of this as a suite of AI and ML tools that you can leverage in your day-to-day work that you do. If you think of Azure AI Studio as a, say, tool belt, Azure AI Studio is the belt. The different tools that are available to you are things such as the Azure AI Service, Azure Machine Learning, and within that, we have specific tools around speech, vision, language, or our ML Studio where we can start to train our models, fine tune them, or new tools like Prompt Flow where we can test these models out and see their performance. This is the portfolio of tools available to you. And in future sessions, I'll show you a more show and tell of these tools, but I just want you to understand what you have available. What's nice about these tools is if you're going to use one of your own models that you built, one of the published models in the catalog, or one of our models that sit out within the Azure OpenAI platform, you can run it on our Azure AI infrastructure. And thus, as a managed endpoint, you could be hosting Llama 2 models, or if you wanted to use Azure OpenAI service, you can use our Pago or PTU models, which are running on the Azure AI infrastructure. Now, to wrap things up, let's talk about the generative AI journey that you'll be on. And I really think of it as a three-step process that you can go through, or three phases for implementation. The first one is focusing in on copilots and looking at the Microsoft 365 platform for your copilot. When we talk about that copilot experience, what this will help you achieve is understanding things such as prompt engineering and the different techniques and styles that you can leverage when using prompt engineering. And it'll also help you set expectations for the actual groundedness of these models and how you might need to start tailoring your prompts to get more accurate results. When we think about copilots, this will help you be what you can think of as customer zero, help you understand that user experience that your customers will have. And if you want your customers to not just like your product, but love it, that user experience is going to be very vital, and why I recommend that as a first step. The next step will be a low code approach, where we would use a Copilot Studio now to gain further expertise within building generative AI applications or large language models. In Copilot Studio, now you can use a low code approach to use pre built conversation AI chatbots or to build out different prompt interfaces that'll help us start to query data that sits out there. Now, what's nice about Copilot Studio is I can start to augment my model with new data, and we call this context. For models to be more accurate, they need good data, or we can say good examples on how to answer the potential questions that sit out there. And when we talk about prompt engineering and the idea of, say, zero or few shots, we can augment that data and provide more context to the prompt. So when we submit it into the model, our responses will be more grounded and accurate. That Copilot Studio will help you with that process of understanding how you can bring in different types of data to help enrich in the prompt, provide the right context, and hopefully help you start to get more confidence in the actual groundedness of those models. And the last step would be our code first approach. That code first approach is using Azure AI Studio. And here you would be thinking about the host of models that I would want to test out. And more importantly, you could also start to think about things such as LLM ops. And that DevOps lifecycle will be really important on the success of your actual applications. Why I say this is when we think of our test cases for our generative AI applications to understand the accuracy and groundedness, not everything's going to be a logical piece. I expect that if I put in A, B will come out. It's not deterministic. It's very stochastic, which means that you need to experiment with these and use things like prompt flow so it can run through all of your different test scenarios and then give you the results that are the most accurate. And as a developer, that code first Azure AI Studio tool belt will then help you become an expert in this field. Before you start your journey, I highly recommend to get this white paper and to download it. You can see the link at the bottom. This white paper contains the 5 core pillars of AI readiness. If you read this before going on your journey, Hopefully, this will prevent you from having too many detours on that trip. The 5 core pillars that they really focus on starts with the business strategy. How do I know what is the best use case for my given industry or domain, and which models might be the most relevant for me to solve that problem? Another big one is the technology strategy. We're not just talking about AI and ML, we also need to think about our data platforms and how that data in those data platforms are stored and the quality of the data within those platforms. And we need to start to think about how do we host these applications? Do we do these on premise, in the cloud? And how do we scale these applications for our user community? Next up would be the AI strategy, where our data scientists no longer are thinking about building these models, but are trying to understand how we experiment and leverage these large language models for the given problems that we're trying to solve. And that model selection will be one of the key pieces in the AI strategy that they need to think through, and also how they can start to augment that data with different data sources. Next up is change management and trying to think through the organization and culture. And lastly is the AI governance. This will be not just thinking through what is the data privacy issues I have, or how do I prevent malicious use of these models, or jailbreaks, they call this, but also thinking about how to build these large language models responsibly and thinking about responsible AI. This will be very, very important on that journey. So now, where I'm going to leave us is a quote from Kevin Scott. He's the CTO at Microsoft, and I think this quote is a great one. It's a call to action for all of us developers who are wanting to use these large language models. Here's the quote. What should we build with foundation models? The beauty of the platform is that I'm not entirely sure. It's your job and the job of the world's developers, entrepreneurs, and creators to figure that out. This is our call to action. This is us as a developer community, as a business community. We need to start to think how we can bring in new capabilities to these platforms and new use cases. There's not going to be a standard recipe that we can use each and every time. It's going to always solve problem A. A lot of the work that we're going to do is being able to push the frontier of these models into new areas and to work on those models in new ways so that we can start to uncover new patterns. So this is our challenge, and I think this is a great call to action. To achieve that call to action, I will leave you with the Azure OpenAI Service Learning Guide. The purpose is to help you get started and hopefully advance yourself to level 300 expertise. There's a lot of great resources, but I highlight the ones with a star next to them as much watch and share the deck and links for future review. The first link is under Getting Started and is a great video series called Generative AI for Beginners. The next track is Basic and a set of resources that give you an introduction to the Azure OpenAI service that hosts LLM models. The third link relates to a workshop for LLM ops and helps developers understand the tools and the deployment lifecycle. Lastly, you can jump into the advanced track, and there's a link to the Contoso web application shared at Ignite. This link is a GitHub repo with sample code for you to experiment with the application capabilities and learn the building blocks for LLM applications. Hopefully, this guide will help you accelerate your learning journey, and in the future sessions, we will cover these topics in depth, but would like to help you ramp up on the learning curve. Please don't feel you have to complete the full guide, since we'll cover them in future sessions as we progress. So, thank you very much for attending today's session, and we look forward to seeing you in the future sessions. Take care.